So today, medium, check if number is the sum of powers of 3. Given a number n, return true if it's possible to represent n as a sum of distinct powers of 3. Otherwise return false. What the heck? Interesting. Interesting. Is it possible? So this seems pretty straightforward. So at any given time, a number is between like some power of 3 and the next power of 3. So you just would need to subtract that power of 3 from it, or the next smallest. And if at the end your remainder is 0, then it is. If not, then it's not. Seems kind of too easy. Okay, I'll say 10-minute timer here. Okay, so let's say at any given time I should look at the biggest power that is less than it. So I think it's gonna be something like is it log? What is the Python log function? Math.log x in the base. Okay. So this would be power is equal to, so finding the closest power that's less than it. So it'll be like int of math.pow and base 3. Let's go ahead and just print out that power to double check here. So n is 17. Can I just do 4? That's a really big number. Oh, I'm doing power. Should be log. I think this works. Casting it to an int. It should truncate it down. 12, so that's 9, which is the second power. Closest one is 81, which is that. 21, closest one is 9. Just do a small test case to make sure that if it is an actual power 3, let's say it's 27, it should give you 3. Okay. For, let's see, and then let's say chop is equal to math.pow of 3 to this power. While n is greater than 0. Is that right? Actually, while chop, yeah, well, Let's just go by powers. While power is greater than 0, n minus equals chop, and then how would it work? So if at the end you have a what is the biggest remainder that could be at the end? So tests. Okay, so for instance, if it's a number between 9, so you have some things that's like less than 27, so it could be 9, 10, 12, 13. Okay, so if you chop it off and that value that you get is still bigger than the next level, chop divided divide equals by 3 if n is greater than chop, that point return false. Otherwise you have power minus equals 1. Okay, so for instance, if you have number 12, the closest one is 9, you chop off 9 and get 3. Chop off 9, you get 3. And if n equals 0, then just return true. I don't think you need, I'm not sure that you actually need to use power here. Okay, so these ones worked fine. Let's see. Actually, I guess you don't need to chop off every time, right? There are some levels that you can skip. So I think here you say if n is greater than chop, greater than or equal to chop, n minus equals chop. Yeah. And then divide, go to the next level, and if at the next level is still bigger than chop, then you have a problem. Okay, so let's go ahead and run it through here. Let's go ahead and print n and chop here. So 91, you're chopping off 81, so you have 10. And then next level, you have 10 compared to 27. You're not going to chop it off. You're going to divide by 3. This is not quite right because you'd be able to chop 9 off. By the way, this should be integer. So what did I actually want to have happen here? So it should be Okay, yeah. So I think this should have an if statement here. If n is greater than or equal to chop it off, and then divide by 3. Does divide by 3 happen every time though? It should happen every time you go down a level. And so you have 10 compared to 9. So what is the case that I'm thinking of that this is actually correct for? Like, for instance, um, if it's slightly below, the power of 3 that you're dealing with. So for instance, 25. So the closest one is 9. You subtract 9 from it, and it's still bigger. I think here it should be if n is still bigger than your previous value before you reduced it. Yeah. But I don't think this works still here. If you reduce it by the chop, and you still have a bigger value after you reduce it, then that's obviously not good. Okay. Still doesn't work. Okay. So 10, 27. Okay, so at least it got to here. 10, 9, 1, 3. So you're not going to chop off there. So divide by equals 3. So chop is 1 at that point. If n equals 1, I think should be the check here. Or n equals 1. I think I might have incorrectly set the range for the power, but it's fine. So slow. Okay. Answer n equals 1. So if n equals 1, power is greater than 0. I don't know, greater than or equal to 0. Okay. I think at this point, I think I could have said 11. I said true. It's obviously false. It'd be impossible to do it with 9 and 1. So let's go ahead and just print that again. So it should be chopping off 9, chopping off 9, and then getting 2. How did that not? Yeah, so 2. So 2 minus 1, 2, 3. Oh, I see. I think maybe I'm going to try going back to my original n equals 0. Yeah. Very long. It's probably timing out. Or this could have went infinite somehow. How could this possibly be timing out? Every time it goes through the loop, it decrements by 1. Unless power is originally 0. Power 0. Okay. I mean, is it possible for the n value to be 0? No, n starts with 1. I'm pretty sure I tested 1 worked. Okay, so here. This one. Not sure why this is like going infinite. Again. Okay, finally. All right.